Okay. We will continue on the topic is about how to design an industrial UAV. And we are high level, we are on the step 2 demo of our products. And on part 3, for the virtual verification, finite element analysis. Okay. This is my personal information, and I already introduced before, and I will just skip it. Now, if you are interested, you can check the details. Okay, so high level, we will have 8 steps, and for this whole introduction, and we are in the step 2 demo whether we can do it. For step 2, we will break it down in separate parts, and we already completed the vehicle design, and already we complete the CFD simulation, and today we will introduce the strength simulation. Okay. Regarding the finite element analysis simulation, and here is the 3D model for the design. This is only for the prototypes. We have the frames, we have the sensors and all accessories, and the interface to mount the payloads. But for the FEA simulation, we only focus on the weight. So we need to replace the small parts, such as sensors, accessories, and with a mass point. And also we need to remove the bolts. We set up connections as boarded connections. And we will fix the boundary conditions. We will fix these 4 ends. And also the payload will be applied on these 4 interfaces, and the battery weight will be exacted on these 4 brackets. Okay, so high level speaking, and the 3D model for the simulation, we will keep the main structure of the frame, the tripod, and the arms. Okay, we will apply all the payloads, all the battery weights, and different position of the 3D model. Okay, this is the inputs for the FEA analysis, such as payloads, battery weight, and the other parts of the weight, and the empty weight is 25 kilogram. And for the different materials, for the frame materials, we will use aluminum alloy. And for the arm and the tripod material, we will use carbon fiber. And for the main brackets, we will use the steel. And for all other connection brackets, connection joints, we will use aluminum alloy. And also, to simulate the worst case, we will apply a acceleration 20 meters per square seconds. Okay. So again, we will go to how to perform the simulation step by step, and this is a how to say very detailed guideline on how to perform the FEA. And when we open the ANSYS workbench, we select the static structure and left click and drag to this area and release the click, and then you can see the interface. Then we will double click in engineering data. Okay? We will find the material area, and we will add the material we will use, such as aluminum alloy. We will use 6061, and the carbon fiber we use 230 gigaparts, and the structure steel. We will not use this one, and this is the default material, and then we just leave it here. Okay. So second one, after we complete the engineering data, we will link the geometry, and then we will go to this interface, and we will click the file and import external geometry files. Then we will select the files you want to use. Yeah. Okay. After we generate, then you can find a 3D model here. So for the 3D model, we need to check the details to make sure we remove all unnecessary surface here, and we also double check the 3D model. There is no singularity. The contact face and the assembly status are the same as what we wanted, and also it's suitable for the finite element analysis software. Okay, after we close the geometry, we will go to the model and double click here, and we will go to the geometry area and click the plus, and then you will create the mass point. Yeah, as I mentioned before, we will, because we have 4 brackets to hold the battery weight, so we will apply 4 battery mass point and 2.2 kilogram for each. And also we will apply the loads here, and 4 different loads. The loads is 2.5 each. Yeah, we will apply all those loads mass point on the brackets and the relevant interface. Okay, so next one, we in the geometry section we will set up the parts material. We click the parts, yeah, select these parts, and click here. We will select the different material, and the first one is the frame beam. So we will use the aluminum alloy 6061. And for all other parts, we will repeat is 10 and 11 the operation and to assign the material. But how to assign the material depends on your design intention. So the details is as the right side picture show. Yeah? For all the arms and the tripod supporting tubes, we will use the carbon fiber, and for the brackets and for these main brackets, we will use the steel. And for the frame, for all the connection, we will use aluminum alloy. So we just want to repeat the 10 and 11 steps and assign the material for all the parts here. After we complete the material assignment, and we will go to the connection, we will set up each components and to define the connection for each other. And firstly, we all those connections will be generated by the ANSYS software automatically, but we need to double check whether the connections are right or are the same as our intuition or not. So we need to double check all those connections. Yeah, so we click on this, and for the contact, you can find the interface. Yeah, these two. So you need to select the surface and apply. Click here, select the surface, click apply. Then for this contacts would be set it up, and we will select all the contacts step by step. Yeah, we need to repeat 13 to 15 to set all the contacts. This contact is arm and connections, B frame connections, tripod connections. For each connection, we need to set accurately. Okay. After that, then we click the mesh and we generate the mesh. Yeah. So the whole mesh will be completed. And if needed, you can right-click the mesh and insert the sizing, and you can set up the sizing for different parts. Yeah, especially for some small parts, you need to specify the meshing size properly. The next one is we need to right-click and add the acceleration and add the fixed support. Yeah, for these two, we use the acceleration to simulate the drone flying and accelerate in the real condition. And the fixed support is to simulate the end point. Okay, and then we click on acceleration and we define the acceleration direction, and is minus 20, yeah, 20 meter per second square. Okay. And next one, we need to fix the full surface, yeah, and right click apply. Okay. The last one is about the solution, and you move your mouse on the solution and right click and insert the stress, equivalent stress. Yeah. Okay. Then the final one is solution solve, and after we have the results and then we check the results, we can find the maximum stress point and check each details for the main frame brackets. Yeah. Okay, we can get all the results, stress distribution. And finally, finally we need to analyze all the stress results, yeah, such as the maximum stress, and we find, yeah, you can check the details or find that there is some singularity here, and it it is will not be the same as the real condition in the real world. We will not the stress will not behavior like this, so we can ignore it. But for other parts, you can see here, this is the worst condition area, and this is the main brackets. You can check the colors, and the stress is 180, and this is the stainless steel, and the stress is 230. Some stress like that, so it can meet the requirements. So after your analysis all the details of the stress distribution, and you can have the judgment that all stress can meet the design target. Okay. Okay, so that's all for today's sharing. And again, here is our social media accounts. And if you have any questions, just leave me message, and or you can reach out to me through all these social medias, and we will respond to your request as soon as possible. And also, we want to share all those data for the 3D model, for the analysis model, and also we will share the presentation on our official website. And if you need that, just let me know. Okay, thank you.